Hey guys, it's me again, testing the new Camtasia, new to me. If you hear an airplane in the background, microphone's pretty sensitive. Probably you don't hear it. It's pretty high. We don't have a huge number in this neighborhood. It's not a lot of airplanes, but we're not that close to an airport. We can also hear trains from here. We can hear the noises they make as they go through town. Portland is very train friendly in the sense that trains have a strong right of way right through the east side of town. And it's the cars that have to stop, obviously. So I am coming to you from Portland, Oregon. Not sure if you've been reading the screen as I introduce myself. I'm Kirby Erner. I'm kind of a curriculum developer, and I spend a lot of time here in Jupyter Notebooks. And the last couple videos were focused very concertedly on this particular curriculum, which I call Python for High School. Basically, taking everything a graphing calculator can do and taking all the topics typically included in a college prep high school of the 1970s or 80s, right? Let's just take a time slice. So there's pre-calculus. So you're going over all the conventional stuff that most math teachers working today would well recognize, right, as, pretty good prep, college prep. But we're not using just a graphing calculator. We're introducing Jupyter Notebooks. So that was the last few videos, and woven throughout here because I have kind of a bouncing around style about my teaching pedagogy. My andragogy is bounce around spherical pinball machine. And this Chaos in the Virtual Library article at Meta Designers by John Wood, this goes back to the 90s, 94. It's about exactly this topic of nonlinear versus linear. And of course, text is being overtaken by hypertext in these early 90s, mid to late 90s. They're still using SGML. People don't remember that might be the root sort of thinking around HTML. There's a lot of history. And as we get into 2022, 2020s in history, there's a lot of interest and focus on just going back. It's kind of like the Fibonacci numbers. To get the next frame, you kind of need to know at least some recent history and technology especially. You need to kind of just to see where we're going and where it's coming from. So Chaos and the Book reminds me of Bazaar and the Cathedral, right? Or Cathedral would be the book. And Chaos is more the Bazaar. But that was for software development, sort of decentralized, an argument. That's by Eric Raymond, right? The Cathedral and Bazaar. This is a different fork or branch in thinking in the 90s, centered around Vannevar Bush and the Memex idea, coming out in Atlantic Monthly of, I believe, 1947. Wasn't that? Or am I off? So early, late 40s, they were already thinking about search engines. This is before the internet in its current form. So order within chaos, and then there's an interesting special case study that these authors undertake. If we go to Mapping the Mapper, I'm going to have, of course, these URLs in the description. And then I'm going to move to Martian Math as a topic. Really, what we're talking about here is cultural communication, intercultural, subcultural. So here I'm kind of in an academic culture, and they're talking again about the concept of mapping, which you need to link to graph theory. You need to think in terms of nodes and edges and all that, and that's where hypertext takes you. It always has. You can talk about adjacency matrix. These are all topics in my high school math here, because we don't shy away from graph theory, and we're especially keen to get across that a polyhedron, a kind of wireframe look at a polyhedron, is itself a type of graph. And then applying this to modes of thought and modes of learning, what you might call chaotic is actually, according to these authors, more prone to lead to induction, abduction. Abduction. Abduction, I'm just learning, is a term that Charles Peirce, the American pragmatist philosopher, wanted to introduce into logic. And what does it mean? And is it true that hypertext promotes abducing? And how is that different from adducing? Abducing, abduction, but you can see the transition here from the concept of abduction to what I call Martian math. And here's your opportunity. It's like you're a science fiction writer. You're always looking for that alien civilization, and you want to give because it's alien, it's kind of disappointing if they have exactly the same math as you do. So you want to give a hint as a writer, you got your imagination in your canvas, and you want to paint like some kind of alien math projected onto this species, these ETs, and that's what we do here with the Bucky Fuller stuff. And what a lot of people have not realized yet as of 2022 is you can go a long way you can do a pretty big fork in standard math and go off in this alien direction based on a different approach to unit volume. Take the tetrahedron as your unit of volume. Is that non-Euclidean? Well, by the time you're done, yes, because of other breaks from Euclid, you could call it. But again, not that far from Euclid, and Fuller's hero in geometry was the main Euclidean of his age, to whom synergetics' magnum opus is dedicated, i.e. Donald Coxeter, University of Toronto. So what I'm showcasing for science fiction writers, you could say, through my Martian math scenario, is, hey, let's take the Bucky Fuller alternative paradigm and use that to paint these canvases wherein the aliens interact with us, coming from they understand the Bucky stuff, or Bucky channeled them, or however you want to tell your story, right? And there's enough there, it's enough different, how we do area, how we do volume, that it's like abduction. It's like, wow, you can go there. You can feel like for a while you're in this alternative world because it's more believable. You have to do less suspension of disbelief. So these authors, like I'm saying, they're just contemplating how hypertext is going to bring possibly a positive kind of chaos into our learning methods. And they're picturing this, and they've gone ahead and developed an actual website where we can explore Fuller's ideas in kind of a hypertext form. And so I'm trying to find the article on that. Where do I want to go there? It says see Buckminster Fuller. Let's go to Paul Taylor's website. And here we are. It's called a Fuller map, and it's based on the idea of idea base, which is based on the idea of it's not specifically HTML, because the way the links are made behind the scenes, we don't really see how that works. But as you go through this, okay, there's an index, there's a search facility. You can just kind of bounce around in what I call a planet or a namespace, a shop talk. And this is the one that you fish up when you go in looking for what did Buckminster Fuller think. So this is a specific example where you can bounce around within this particular website. It's like feels kind of wiki-like and so forth. But it won't, I don't think, anywhere get that specific about what I call Martian math, or in other words, the concentric hierarchy, which is the core logic that Fuller brings to the picture. And I'm saying this is ripe for more exploitation, and I don't mean that in a bad way. I mean, here's a free resource where you, a imaginative, creative author, screenwriter, whatever, are looking for raw material that, like with an Isaac Asimov spin on it, has didactic value. In other words, you're imagining your audience of younger people, possibly, and older people trying to learn a new field or review a field, and they use science fiction partly for the science. So it's not that far out that you can't really learn some real science from it. Like with my Martian Math, I'm keen to get into hydropower, and not in some newfangled way. I'm just talking Tesla. I'm talking how we do AC DC, how we do the conversion, how we do HVDC, how we do power grids, all that stuff, not just batteries and light bulbs, right? I want to do big loads like cities as what we conceptually play with, as in SimCity, right? So real simulation mindset. Video games are intelligent, and they're not just first person shoot 'em ups, right? We're tired of that as a genre if that's the only option. So here we're kind of out in the desert. We got your average sort of, you could call it a shack, but it's pretty nice. And I try to summarize in this picture some of what people get wrong about the dome. Like you see that ladder with the TV, like you're climbing up on a bunk bed or something. That's just giving the idea that you can have your rectilinear structure inside your dome and not worry about how do I push the fridge up against the wall. Because the shell is enclosing more of a garden. It's a much bigger space than just your rectilinear sort of theatrical theater props, which you can swap out. It's much easier to remodel and redecorate when you don't confuse the structural integrity layer with the theater layer, or what we could call the floor plan, whatever. And I'm just sneaking in here a little bit of buckiness in that I'm measuring energy, which we can easily see as a volume measure anyway, right? There's nothing wrong with a cubic unit of energy and actually picturing a cube, because we want energy somehow to translate to the volume, potential plus kinetic and so on. A conserved liquid, right? It's not a bad idea. It's a lot of physics will go there. Talk about energy in terms of something that has shape and volume. So once you go there, if a unit cube's okay, then a unit tetrahedron should be okay, right? So a joule could be a unit tetrahedron of some kind, and that's how the Martians think, or the ETs. And then we can immediately say, if we're kind of trying to get on with things, let's forget about that for now and go back to XYZ vectors and polyhedra. So I'm right back to, like I say, ordinary, conventional, kind of the high school I got when I went to high school. This is a faithful carrying forward. And having been a high school math teacher subsequent to going to Princeton, hey, I have enough street cred to say this is the gist, okay? And I'm also role modeling for students how to do attribution. These are copyleft kind of things from Wikipedia and others. They have, and then I do my own work. We do a ray tracer and so forth. But the Martian math is here in a very muted form there. Like the tetrahedron's there and a possible coordinate system of 4 basis vectors. You know, we have a lot of coordinate systems floating around, and this is another one. It's called quadrays. But I don't get into that in this particular module. These are just XYZ vectors. We learn to add them and scale them. Rotation brings in a matrix if we get to that section, which is perhaps a segue, right? Anyway, this is the subject of the most recent videos in case you want to go back there. But what I'm adding here is, hey, if you're into science fiction and you're also into teaching culture of any kind, here's an overlooked opportunity. Take a real, something you can develop, alternative paradigm, and mix that in as what the ETs are using, so that you can now bounce off that. And it's not like I'm giving away the one plot that would go with that. For me, it's working with the ETs on a hydro dam projects and learning electricity and stuff. But that's just my adaptation, right? What I'm inviting you to do is take advantage of this alternative paradigm where we have a cube of volume 3, right, relative to this tetrahedron. You know the volume relationship, right, about face diagonals and all that stuff. And then that same cube of volume 3, you can crack it up, fracture it, and this whole idea of polyhedral dissection, right? And forget about doing it Fuller's way if you don't like it, right? Some people with different nomenclature learn his way of doing it as one among many. And again, this is a multinational effort. I'm crossing borders willy-nilly without a passport, just by virtue of the internet. Thank you, internet. Like, I'm just spreading ideas here. So wherever you're getting them, think of them as having some indigenous place-based context for you to work out. Like, I do casino math here as one of my 4 major math branches, see my heuristics for teachers. But we have a lot of casinos out here, and our economy as a state depends on the video lottery and stuff like that. So in my culture, we gamble, and that's where probability, combinatorics, all those topics logically enter the picture, right? This is I'll just take you there as I sign out, my digital math. This is a new computer, so it doesn't have all the same built-in links, so I have to go there. Introducing Oregon math. So this is somebody interesting. Okay, not my site. Here's me. Digital math wiki educator, but I am reaching out within Oregon. So I have an Oregon Silicon Forest sort of local perspective. So I don't want you to see me as some kind of, missionary who's trying to shake the tree against your will in your section of the world. The whole point of my spiel here is that I have a particular way that makes sense in this neck of the woods of communicating this material. But what I'm offering you is adaptable and could just be one influence among many by the time it gets to your neck of the woods, right? So check all this stuff out, and especially if you're in Hollywood or into computer graphics, think about developing a career with more input from the aliens, right? I could say the Martians, but that's been taken. That means the Hungarians. That's kind of insider talk. The Hungarians made a huge difference here after World War II, up to actually during World War II. What am I saying? And I'm talking about people like von Neumann, right? I have a whole book on it. It's called The Martians, and it's about Hungarian intellectuals. I think we focus too much maybe on like how a lot of like former like it's not all about Germans and those kind of operations, paperclip and von Braun, and okay, that story is being told a lot, but let's focus on the Hungarians sometimes. Anyway, a little bit of footnote there, and let's talk again soon.